Hello there, welcome to the October 2020 core paper 1 for A2 further maths, full A-level further maths. Here we're looking at question 1. So we have f of z, which equals 3z cubed plus pz squared plus 57z plus q, where p and q are real constants. Given that 3 minus 2 root I is a root of the equation f of z equals 0, show that all roots of f of z equals 0 on an argand diagram. So what we need to do is find the other two roots then. Now we know the second root immediately because it's just be the complex conjugate of it, because when we have real coefficients, then a polynomial that's equal to 0 will have complex conjugate paired roots. So therefore if alpha equals 3 minus 2 root 2i, then beta equals 3 plus 2 root 2i. Okay, the next thing to do now is to use this 57 here. Now 57 is in the position where we have to use the formula for the sum of the doubles equals c over a. So let's go ahead and now use this formula. So we'll call the third root gamma, obviously. So it's going to be 3 minus 2 root 2i times 3 plus 2 root 2i, add 3 minus 2 root 2i times gamma, and then add 3 plus 2 root 2i gamma equals c over a. This value is c, the first value is a, so 57 divided by 3 is 19, so equals 19. Okay, so the next stage will be to expand all these brackets. It's going to be 9 plus 6 root 2i minus 6 root 2i, so that would just cancel, and then it's going to be 2 root 2 times 2 root 2, that would be 8. It would be a minus, but then I squared would give us another minus, so then it would just be plus 8. Then it's going to be plus 3 gamma, and then it's going to be minus 2 root 2i gamma and plus 2 root 2i gamma, so that will cancel out. So then the next bit would just be 3 gamma again, equals 19. Let's then subtract the 9 and the 8 onto the other side, and that would be 6 gamma equals 2, so therefore gamma equals a third. So there we are, so that's the third root, and the argand diagram will look like this. It will have one root at a third, it will have another root at 3 plus 2 root 2i, and it will have another root at 3 minus 2 root 2i. So there we are, that's the answer for part A. Let's now move on to part B, find the value of P and Q. Well, I think what I'll do here is, instead of, we could do the sum of the singles, couldn't we? So add the singles equals P minus P over 3. So that is going to be 3 minus 2 root 2i plus 3 plus 2 root 2i plus a third equals minus p over 3. Let's simplify the left hand side first. It's going to be 3 plus 3 plus a third, that would be 6. So 6 plus 1/3 gives us 19 over 3, so it would be 19 over 3 equals minus p over 3, so therefore p is minus 19. And then the last one will be the sum of the, just the triples, alpha, beta, gamma equals minus d over a. So that's going to be 3 minus 2 root 2i, 3 plus 2 root 2i multiplied by a third equals minus q over 3. So let's multiply it out to the first two brackets. It's going to be 9 and then plus 8, so that would be 17. So 17 times a third is minus q over 3. Cancel out the third on both sides, and we get q equals minus 17. And there we are, that's the answer for this question here then. So it's the sum of the singles, sum of the doubles, sum of the triples kind of formulae, the roots of polynomials chapter there. So there we are, that's the answer for question 1 from this October 2020 paper. Let's now move on to question 2.